We know where it ends up. We know that it turns around. So this vehicle is going out, it hits some point where it turns around and then comes back, and it ends up 112.5 meters from where it started. So now if I ask the question, what was the distance it traveled? 112.5 is not the answer, because it turned around. The distance it traveled is whatever that is plus whatever that is. So the first thing we need to do is figure out, where does it stop? We have to figure out how far does it go out that way. At what time does it stop? When it stops for just a brief moment as it turns around, like throwing something up into the air at the peak, it turns around, it stops for just a brief moment before it starts going back down. If something is stopped, what is the velocity? All right, so at what time is the velocity 0? All right. So it takes 10 seconds to get to the turnaround point, and then it comes back for 5 seconds. So this is 0 seconds, plus 10 seconds, and then 15 seconds at 0. Well, let's figure out how far does it go out that way in 10 seconds. What's the, for that 10-second period, what's the average velocity?
15.
Yes. So on average, I'll call it V average plus, while it's moving in the positive direction, 15 meters per second. Again, it starts at 30, and then in 10 seconds it's going 0, average the two numbers. So it's going 15 meters per second that way. So how far does it go?
150.
Yeah. So 15 meters per second for 10 seconds. At this point, it's 150 meters. I know it ends up 112.5 meters, so what is the distance from this turnaround point to where the problem ends? Or how would you find it?
Subtract.
Yeah.
37.5. 37.5.
So that is how far it travels this way. That's a displacement, after it stops, that's a displacement of negative 37.5 meters. But what we care about is the distance traveled. So what is the total distance that this vehicle actually traveled?
Would it be 187.5?
Indeed it would. It goes 150 meters in the positive direction, it stops, it turns around, comes 37.5 meters back. It ends up this far away from the starting point, but it travels 187, just 150 plus 37.5. So the distance traveled is 187.5 meters. What is the average speed? Or how would you find it? How do you find speed? I wasn't sure whether you were saying an answer or not. Okay. You're driving in a car, what are the units for your speed? Yeah, miles per hour. Per means division over. So it's miles over hours. It's a distance over time. I know the distance, how much time did it take? How much time did it take to go 187.5 meters?
15 seconds.
Yes. So my average speed no vector symbol, is the distance, again, no vector symbol, divided by time. So that is 187.5 meters divided by 15 seconds, and that gives something bigger than 10.
Yeah.
Per second. So my average velocity is 7.5 meters per second, positive. My average speed, 12.5 meters per second. This is similar to a master set question and similar to what will definitely be a test question. But the master set question apparently is a little bit less straightforward about what time it stops. So questions about this before I make it more complicated. All right, so we know the time it stops here just by working through, when we subtracted 3 each time and it happened to hit 0 perfectly. Great. However, there's got to be a different way of doing it if it doesn't come out perfectly there. So what I'm going to do is, well, basically, I'm going to use this formula right here. The only difference is, this is what we're trying to find now. My acceleration is -3, it's given in the problem. That's going to be equal to my change in velocity. So I'm starting out at 30 and I'm trying to figure out how much time it takes to stop. What will be my change in velocity? If I start out going positive 30 meters per second, and I'm trying to figure out how much time it takes to get to stop, what is my change in velocity? I know you're just so overwhelmed with how incredible physics is that you're almost speechless. So let's take a shot. Worst that happens is you're wrong. Pardon?
-30 meters per second?
Take the question mark off of it. Say it with great confidence.
-30 meters per second.
Yes, yes it is. Because again, change in velocity is final minus initial. I'm starting at 30 and trying to figure out where 0 is, so I'm going from 30 to 0. 0 minus 30 being -30. -30 divided by time. That's my problem now. If you prefer more fractions, I can stick 1 under anything. If you cross multiply, you got 2 diagonals there. One of the diagonals has an unknown. So you multiply the diagonal, which is known, and divide by the number left over.
+10. +10.
Yes. Now, first thing, time better be positive here, since we started at time is equal to 0 and then progress. If I got a negative time, that's happening before the problem takes place. Now, that is exactly what we had before, which is good. However, not every problem works out that nicely. It really comes down to my mood when I'm writing, putting the numbers down. My mood or how thoughtful I'm being. Sometimes I just change numbers without thinking the implications. Questions before we actually stick in numbers where we have to do this technique? And I know, I'm reading your minds right now. You're thinking, math, finally, it's like a breath of fresh air just coming over me because I can't get enough math. You're welcome. I'm just gonna simplify all that stuff right there. All of it. All right, so we'll have an initial velocity of 20 meters, 20 meters per second. We will have a final velocity, I won't give you acceleration. We will make -6 meters per second. We will let time be 12 seconds. And, all right. As long as I give you three things, it is possible to figure out the others. Some will be more difficult than others. So I'll try to avoid where you have to use the quadratic formula. I know. You want to use the quadratic formula. Sorry, wrong class. So the questions are, I would write it out. There's an object traveling initially at a positive 20 meters per second. It accelerates uniformly at -6 meters per second squared for 12 seconds. So, question number one. What is the final velocity? Question number two. What is the displacement? Before we do that, what is the average velocity? What is the displacement? What is the time when it stops? What is the distance to stopping? What is the total distance? And what is the average speed? From three numbers, we will get all of that. This, in essence, is what we just did. I just didn't write it this way. And again, I put it in the order in which I would solve it. If you have some inspiration, you don't have to do it in this order. Okay. Let's first find the final velocity. We'll do it two different ways. Now, I'm not going to, on a problem like this, I would not say do it a particular way. I'm presenting two ways. Latch on to the one you like and run with it. So method number one, just the sort of brute force. Let's say I start out at time and I have velocity. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm starting here at 20. Just so I don't get really off here. This was an online paper. All right, so after 1 second, what is the velocity of this vehicle?
14.
After 2?
8. 2. -4. -10. -16. -22. -28. -34. -40. -46. -52.
Zero mistake there. I was just trusting I was being told the right thing. Doing quick checks, but let's see. Yeah, okay. We ended up in the right spot. All right, so answer to number one there. negative 52 meters per second. Please do not forget units. In the final answer. Questions how we got that? Riley?
On the velocity, you're going down -6 meters per second, right?
Yes.
That comes from the average, or the
Acceleration.
acceleration.
Absolutely. Because this tells me my velocity will change, -6 meters per second every second. All right, let's get the final velocity a different way. Because we're all sophisticated people. I know my acceleration is the change in velocity over change in time. My acceleration is -6, and that's gonna be equal to my change in velocity divided by my time, which was 12. So my change in velocity
-72.
-72. And that's gonna be my final velocity minus my initial velocity, because again, change, final minus initial. And I know my initial velocity is 20. So I have -72 is equal to VF minus 20. And 20 to both sides. And again, -52. Same answer as we had right there, feeling good. Again, I'm not gonna specify which technique you should use, they both have advantages. Just depends upon your comfort. All right, average velocity. Oh, questions? Okay, average velocity. Zeta, you look like you want to answer. You wanna let someone else jump off? Average velocity. Hopefully solving it without adding up to 13 numbers.
-6.
-6,
-16?
16. Okay. If you define my average velocity, given the information, it's just the average of the first and last values. So 20 plus -52 divided by 2. -32 over 2, which is -16. -16 meters per second. So this is just average that and that. You'd get the same answer if you added up all 13 and divided by 13. You'd get the same thing. Again, the best method is the way that your mind is working at the moment that you need to do it. All right, displacement. How are we gonna find displacement? What is the displacement? All right, let me ask you a different question. If on average you're traveling 50 miles per hour for 3 hours, how far do you go? On average, if you're driving an average speed of 50 miles per hour for 3 hours, how far do you go?
100.
How'd you get that?
Multiplying.
The average times time?
50 by 3.
Yeah. You multiply the average times the time. I think middle school physical science would be distance equals rate times time. We're doing the same thing here, just that we're dealing with more sophisticated numbers. I got an average of 16 meters per second for 12 seconds. If you've gone average negative 16 meters per second for 12 seconds, what is your displacement? Or what would you do? I'm feeling confident that some of you know the answer, just being shy.
Negative 192.
Was that
Negative 192.
negative 192?
Yeah.
How'd you get that?
Negative 16 times 12.
Yep, absolutely. Units?
Meters.
And for those who missed what she did, I know average velocity is also equal to my displacement divided by time, or displacement is equal to average velocity times time. So it's negative 16 times 12, which I'm trusting is 190, negative 192. Questions there? All right, the time it takes to stop. We can narrow it down, from looking at this, we can narrow it down between which consecutive seconds it's gonna happen. Between what and what is it going to stop?
3 and 4.
Yes. So at some point in that range, somewhere in here, is it gonna be closer to 3 seconds or 4 seconds?
3.
Yeah, okay. So whatever answer we get, it needs to be closer to 3. Now, if you do interpolation, you can see it's gonna be 3 1/3 seconds, but potentially you're not working